Hi everyone, today we are going to be looking at how do we solve systems of linear equations through graphing. So we've been looking at linear equations and we know that all linear equations use the equation y equals mx plus b. Well, we're going to continue that information and add on to it today by looking at some graphing in our new chapter of chapter 5. So first of all, we want to know what is a system of a linear equation. So a system of linear equations is a set. It's a set of two or more linear equations in the same variables. So they would have two or more linear equations, and at some point they will work together. So it's a set of two or more linear equations in the same variables. All right, so let's look at what are some examples of a system of linear equations. So we have our systems, and it's two or more linear equations. Okay, so two or more. So here is an example. I have y equals x plus 1. So this is equation 1. And I have y equals 2x minus 7. Equation 2. Now, these two systems, or these two equations, work together to create a system. So we have equation 1 and equation 2, and we can use the two of these to solve for x and to solve for y. All right, so how do you know that they can work together? So when they work together, you get a solution, or a solution of a system of linear equations. So we will have our next set of words is called a solution of systems. Of linear equations. So when you have a solution, it means that they create an ordered pair of x and y. These words are really long, and I apologize for that. So the solution of the system is two variables that make an ordered pair, and they work together. And it's where they intersect on the graph. So a solution would give, let's see here, gives two ordered pairs that intersect at one point on the graph. So, for example, if I were to graph one equation and then I graph another equation, a solution would be where they intersect. Okay, so you have two equations that work together to give ordered pairs, and then from there, those will intersect one another to give you lines that work together like that. Okay, so let's put this into action and see what this actually looks like. when you have either a system of linear equations, the two or more linear equations that are going to work together using those same variables, so x equals whatever, and then we're going to look at if they are a solution by their graphing. Okay, so our first example looks like this. We have they want us to solve by graphing y equals 2x plus 5. That is equation 1. And we have y equals negative 4x minus 1. This is equation 2. So as you can see, we have two different linear equations because they both follow y equals mx plus b. And we're going to see now if they are a solution through graphing. Okay, so we'll see if they are a solution by using graphing. Okay, so let's go ahead and graph and see how these equations go together. All right, so we're going to graph this by looking at the y-intercept, and then see where they cross over together. So let's go ahead and start with our graph. So yours, again, already has these little lines on it. If not, go ahead and draw them. And we're going to start with y equals 2x plus 5. So we know here that y equals 2x plus 5. This means that x, so let's look at equation 1. So equation 1, we have y-intercept is 5, which means the x is 0. So we're going to go to 0, 5. So 0, and then 1, 2, 3, 4, and 5. Put a dot there, and then we have a slope, our m equals 2 over 1. So we're going to either go rise 2, 1, 2 over 1, or down 2 over 1, down 1, 2 over 1. And now we can draw our very first line. So here is the line for number 1. Okay, now we're going to look at our line for equation number 2. So equation number 2, it starts at negative 1. So negative 1 with x being 0. And then our slope, so m, our slope is negative 4 over 1. So that means our slope is going to go at an angle going downward. Okay, so let's go ahead and look at this one. So we're going to start at 0, negative 1. So here's 0, and then negative 1. And then we can go up and down 4 over 1. So we're going to go up 4, 1, 2, 3, 4 over 1. Ooh, look at that. And then down 4, 1, 2, 3, 4 over 1. And we're going to just draw our line. And look where these two lines intersect. They intersect at negative 1, 1, 2, 3. So our solution or our system to this equation is negative 1, 3 is the solution. It's where the two lines go together or cross over on their graph. So that is the solution. The solution is x equals negative 1 and y equals 3. Okay, so go ahead and write this one down, get this one graphed, and we're going to do another example. I'm going to turn my page. Okay, on this example, Let's look at our two equations. So on example B, we have two equations here. And our first equation is y equals negative 2x plus 2. And y equals 3x minus 3. So here is equation 1. And here is equation number 2. All right, again, we're going to start with graphing. So we're going to want to make sure we have our graph paper. Oops, there we go. Oh my, that's a little bit better. I feel like this thing got all messed up for some reason. Okay, now we're going to go ahead and draw our line, our x-axis and our y-axis. All right, so let's talk about the first equation. So equation number 1. Equation number 1. Our y-intercept is 2, which means that x is 0. And then our slope, so here's our b, and our slope, or the m for equation 1, is negative 2 over 1. So again, negative is going downward like this. So we're going to go ahead and graph this. So we're going to start at 0, 2. So we're going to go to 0 and then go up 2. 1, 2. That's where it crosses the b. And now we're going to go down over 1. So down 2, 1, 2 over 1. Down 2, 1, 2 over 1. Up 2 over 1. Up 2 over 1. Okay, now we can connect our line. There we go. And we have equation 1 graphed. Okay, let's look at equation number 2. Equation number 2 is right here. The y-intercept is at negative 3. So remember, it's at negative 3 because this should really be plus a negative 3, which means that x is 0. Our slope is 3 over 1. 3 over 1. It's positive, so it's going to go up that direction. Okay, so let's go ahead and look at this and decide where to begin. So we're going to go to 0, negative 3. So 0, 1, 2, 3, put our first dot. And then we're going to go up 3 over 1. Up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3, 1. Okay, so now I can connect these. Okay, and it looks like it crosses right here over at 1, 0. So our solution to this system is over 1, 0. So 1, 0. We could also double check this by putting our solution of x equaling 1, and we should get a 0 on the outside of our equation. So if I take equation 1, which was y equals negative 2, and I put 1 in for x plus 2, that's negative 1 plus, that's negative 2 plus 2y equals 0. And then in this one, if I were to put y equals 3 times 1 plus 2, I would get 3. Why did I mess that up already? This should be minus 3. Minus 3. Minus 3, y equals 0. I wrote down the wrong equation. So make sure when you're writing your equations that you write the correct thing. 3x minus 3, 3x minus 3. Here, let's just rewrite that. 3x, or 3 times 1 minus 3, 3 minus 3, y equals 0. There you go. That one's easier to see. Okay, and because now we have 0 and 0, you have a solution. They both equaled the same thing when x was 1. So the solution is 1, 0. And also you can see that right here in the graph. That's our solution, where they intersect. Okay, it is your turn to do a try it. So as you do your try it, I want you to remember to graph, and then if you want, you can also check your work there. Okay, so the first one that we're going to look at, or the try it that we're going to do, says equation 1 is y equals x minus 1, and equation 2 is y equals negative x plus 3. Okay, so go ahead and look for how to graph. Hit pause right now so you don't hear me solving. And then when you're ready to check your own understanding, go ahead and hit play. All right, so equation 1. Our intercepts, so we want to look for the b. B equals negative 1, and x means 0 then. That's where it crosses the y. And then we want to know our slope. Well, the slope right here, remember this is an invisible 1. So our slope is 1 over 1. That is our slope. So m equals 1 over 1. So let's go ahead and graph this equation first. So we're going to go nowhere, and then we go to negative 1. There we go. That's our first one. And then we're going to go up 1 over 1. I was doing this one. So up 1 over 1. So we have just this like line that's going to go like this. Teeny tiny dots. Why do I keep making dots there? Okay. Ignore those 2 dots, please. Now I'm going to connect these. Okay, now we're going to look at equation number 2. All right, equation number 2 says that b is when x is 0 and it's at 3. And our slope, again, we don't have anything there. And so it's just a 1, so it's negative 1 over 1. So we're going to go to 0, and then 1, 2, 3. Again, this one is a negative slope, so we're going down and over, down and over, down and over. And if you look, you can see right here that it crossed. Our line crossed right here, which is over 2, up 1. So our solution is when x equals 2 and y equals 1. 2, 1. And again, you can check your work and see what happens when we put 2 in here. So if we say y equals 2 minus 1, y equals 2 minus 1 is 1, so y equals 1. And then on this one, if we say y equals negative 2 plus 3, if I have negative 2 and I add 3, I get 1, so y equals 1. So when x is 2, y is 1. When x is 2, y is 1. So they have the exact same solution, 2, 1. All right, go ahead and put your level of understanding out to the side. And then I also want you to answer for me your essential questions somewhere on your paper. Your essential question was, how do you find the solution or how do you solve systems of equations with graphing? So how do you solve when you are graphing? What are those steps that we're looking for? What are the steps? How do we solve? So we find the b, we find the slope, graph, find the solution where they go together. So go ahead and summarize that. Put your level of understanding out to the side. And then when you are done, you can come on back to the Google Meet and ask for help, or you can head on over and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.